Hi students, today my topic is kinetic molecular theory of gases. In the previous videos, I explained regarding Boyle's law, Charles' law, Gay-Lussac, Avogadro's law, ideal gas equation, and even I explained Graham's law of diffusion, okay, and Dalton's partial pressure theory of partial pressures. If you want to watch those videos, kindly have a glance. Okay, in this video, I want to explain regarding kinetic molecular theory of gases. Okay, and this theory was first put forward by Bernoulli, and it was later developed by Maxwell, Clausius, Kronig, and Boltzmann. Now coming to the postulates. I think postulates you people know. Okay, molecular theory of gases. Like if you take gas molecule, gases they consist of very tiny particles called molecules. Okay, and these molecules they move randomly. Randomly means they move as if they like, but they move in a straight line. And whenever they are moving, suppose if in a box I'm taking some gas molecules. Okay, this gas molecule it is moving and it is colliding with this molecule. When these two molecules when they collide each other, okay, what is happening? That some pressure is generated. Okay, na? Yes, ma. And these collisions are perfectly elastic collisions. That means there is no loss of energy. Okay, na? And if you take the gas molecules, whatever the distance present between them, that is nothing but intermolecular distance. And intermolecular distance for the gases is very large, and hence the force of attraction between them will be less. Okay, the intermolecular distance will is somewhat large when compared to solids and liquids. Therefore, the force of attraction is less here in case of gas molecules. Is it clear? So, are you clear with this first postulate? Gases consist of tiny particles called molecules and they move in random motion. Random means as if they like. Okay, the intermolecular distance is more, so force of attraction is less. Clear with this? And molecules undergo collisions. Collisions means one molecule will go and hit other molecule. Okay, when they are moving randomly, it happens. Okay, and they are elastic collisions. Elastic means perfectly there is no loss of energy, and they move randomly, and when they collide each other some pressure is exerted, and whatever the kinetic energy which is produced, that is directly proportional to its absolute temperature. That means absolute temperature means the temperature which is measured in Kelvin scale is called absolute temperature. Clear with all these five postulates, everyone? Okay, yes, ma'am. Now when these molecules are moving, okay, suppose if we take one container, okay, and in the containers actually if we take all the molecules and if we keep at one corner, okay, the volume which is occupied by all the molecules, okay, the volume if we keep it one corner, the volume which is occupied by these molecules, okay, is very negligible when compared to the actual volume they occupy. Okay, yes, ma'am. They will take only little amount of space, but what they will do as they are moving freely, they will occupy the entire room. But if we collect all the molecules and if we keep it at one corner, the volume which is occupied, volume means the space which is occupied by them, will be is very less when compared to the actual volume. No, coming to the kinetic molecular theory, whatever the gas molecules possessing velocities, there are three types of velocities. First is most probable velocity, average velocity, and root mean square velocity. Now coming to the most probable velocity, suppose if you take 100 molecules in one container, and in this 100 molecules, suppose 40 molecules are possessing this velocity 3 meters per second. Okay, and remaining 30 molecules are possessing some 2 meter per seconds, and remaining 30 molecules they're possessing 1 meter per second. Okay, in this which is more here 40, that means the velocity which is possessed by most number of molecules is called most probable velocity. Clear, everyone? That is nothing but here 3 meter per seconds. Is it clear? Most probable velocity means the velocity which is possessed by maximum number of molecules is called most probable velocity, and most probable velocity is denoted by the letter alpha. In the formula of most probable velocity, alpha equals to square root of 2 RT by m, stands for ideal gas constant, that is universal gas constant. I think you know the value 0.0821 atmosphere per Kelvin mole, or else 8.314, or else 0.002. Okay, temperature it is measured in Kelvin scale. M means the molecular mass. Suppose if you take hydrogen, you will take 2. Helium means you will take 4. Oxygen means you'll take 32. Okay, this is the molecular mass of the gas. Is it clear now? Most probable velocity means the velocity which is possessed by most number of molecules is called most probable velocity. Now coming to the average velocity. Okay, the average velocity means, suppose if you take this one only. Okay, here what is average velocity? 3 plus 2 plus 1. Okay, or else, sorry, what we need to do, 40 into how many molecules are possessing this velocity? 40 into 3 plus 30 into 2 plus 30 into 1. Okay, divided by total number of molecules is 100. If we do this one, that means it is the velocity which is occupied. It is the average. The average means here will not divide it by 2. Here we will take arithmetic mean. It is the arithmetic mean of the velocities of the molecules. Is it clear? Arithmetic mean of the velocities of the molecules is called average velocity. Now coming to the root mean square velocity. Root mean square velocity, and listen, average velocity, the formula is given by square root of 8RT by pi m. Okay. Now coming to root mean square velocity. It is the sum of velocity square of all the molecules divided by same arithmetic mean only. Okay. It is a arithmetic mean. Sorry. It is a square root of the average of the squares of different velocities of the gas molecules. I am saying it again. It is the square root of the average. Average means arithmetic mean of the square of different velocities of the gas molecules. Clear everyone? It is the square root of the arithmetic mean of the squares of different velocities of the gas molecules is called root mean square velocity, that is denoted by the letter u, and this formula u equals to square root of 3RT by m. Out of these three velocities, most probable velocity, average velocity, and root mean square velocity. Root mean square velocity is more, and then average velocity, and then most probable velocity. See here this. Okay, root mean square velocity is greater than average velocity, greater than most probable velocity. Why? Because it is 3RT by m, root 3RT by m. This is root 8RT by pi m. If root 2RT by m, if you cancel that one, you will get the values. Clear everyone? Now, now I want to derive the relation between temperature and kinetic energy. What is the relation between temperature and kinetic energy? Okay, see here. Suppose if we take one container or else one cube, okay, which is having equal dimensions, and the length is L. Here length L, cube, I think all sides are equal, right? Let m be the mass of the molecule. Let n number of molecules be present, and let the mass be m of each molecule. Okay, na? Yes, ma'am. And here I think you people know, if they are moving in x direction, we'll take the speed as vx, vy, vz. And this one you'll teach in you will learn this one in physics, but in a different manner. Same concept only, but you will take some factors like I, z, or something like that. If the molecule is moving in next direction, we'll take Vx, y direction is Vy, Vz. If it is moving in z direction, okay. But let us take all these velocities are same, okay. Suppose if you take this same like this, okay, now listen, ma. First thing, pressure. Sorry, if you take momentum means, what is the momentum formula? Momentum means mass into velocity. Okay, just remember, I think this one you will learn in physics. Momentum means mass into velocity. Suppose if the molecule is moving like this one, and it is coming this one, what is the momentum here? mv. Suppose if it is moving in x direction only, mx. And when it is going to the starting point, what you will get? You'll get minus. What is minus represent? That means it is change in direction. Okay, what is the change in momentum here? Change in momentum equals to mvx minus mvx. Okay, so what you are going to get? That is nothing but 2mvx. Is it clear? No. Force equals to, I think you know, change in momentum by time taken. Okay, change in momentum by time taken. Okay, and time. If we take time, what is the time formula? Distance. Let it covered by distance of L. So what is L by, what is the velocity here? We are taking it as Vx. So in place of time, shall we write this one? So change in momentum equals to 2m Vx by, what is the time we got? 2L by Vx. Okay, this 2 and 2 gets cancelled. So what you are going to get? M by L Vx square. Is it clear? Okay, we got, what is the total velocity? Total velocity equals to Vx plus Vy plus Vz. Let us square this one. V square equals to Vx square plus Vy square plus Vz square. Okay, and I already said, let us assume that they are moving, elastic, let the velocities be same, so we can write V square equals to 3 Vx square. Okay, so Vx square equals to what we can write? 1 by 3 V square. Okay, so apply this one here. So what you will get, in place of Vx square, shall we write this one? 1 by 3 V square. So what you are going to get? Force equals to 1 by 3 mv square by L. Okay, see here, 1 by 3 mv square by L, this force equals to, now pressure equals to, what is the formula? Force by area. Okay, in place of F, just substitute this one. What you will get? M A by L. What is area here? Area is nothing but length into length, L square. So what you are going to get? Pressure equals to 1 by 3 mv square. Mv stands for velocity, and here you are going to get volume. So convert, what you will get by pressure into volume equals to 1 by 3 m velocity square here. Okay, clear? This is the formula, and now you will find out the relation between them. So we got PV equals to 1 by 3 mv square. For n number of molecules, you are going to get 1 by 3 mnv square. This is first one. As per the ideal gas equation, what we can write? PV equals to nRT. This is second relation. Just relate these two. Okay, what you are going to get? 1 by 3 mnv square equals to nRT, and then gets cancelled here. So what you will get? mv square equals to 3RT. Okay, just divide it by 2 on both sides. So what you will get? 3 mv square by 2 equals to 3RT by 2. Okay, this is nothing but we can write it as a half mv square equals to 3RT by 2. Half mv square is nothing but kinetic energy, right? So kinetic energy equals to 3RT by 2. This is the formula for kinetic energy. So you can apply this one. Kinetic energy equals to 3RT by 2. Is it clear, everyone? Okay, so as the temperature increases, kinetic energy also increases. This is, suppose if you want for some particular number of molecules, like suppose if you want only for 1 mole, okay, yes, for 1 molecule you want, so 3RT by 2 into 1 mole means n number of molecules, right? We'll write n here. So what is the value of R? 8.314 joule. Joule means 10 power 7 x, right? Into 10 by 2 into 1 mole means how many molecules? 6 into 10 power 23 molecules, right? If we take this one, what you'll get? 3 by 2 T into 1.38 into 10 power minus 16. Okay, you will get something value. So this value is nothing but K. K means Boltzmann constant here. So 3 by 2 KT we can take for kinetic energy, or this formula you can apply. Both formulas are for kinetic energies only. Okay, this is for 1 molecule KT, and this is for entire molecule. Is it clear, everyone? Okay, and in this video today I taught most probable velocity. Most probable velocity means the velocity which is possessed by average number of atoms. Okay, and average velocity means it is the arithmetic mean of all velocities. Okay, RMS means it is the square root of squares of the velocities together. Okay, and momentum and kinetic energy formula means 3 by 2 RT or else 3 by 2 KT. Okay, now, and kinetic molecular theory of gases. Okay, right? And if you have any if you have any doubts in this video, please do write in the comment section so that I'll clarify. Okay, and if you like my video, please do like, share and subscribe to my channel. Thank you students, thank you very much. Bye.